So we have three projectiles that we've been looking at this chapter. We have our horizontal launch, our angle launch where we start and end at the same position, and we have the angle launch where we start and end at different positions. So for this section, we are going to particularly focus on our three favorite graphs: position versus time, velocity versus time, and acceleration versus time. And what's nice is for the horizontal direction of all of your projectiles, we know that the acceleration working on it is always 0 because we're ignoring air resistance. We know that that velocity is going to have some constant value, and because of that we also know the position time graph will be constant. So whatever the slope is of our position time graph, we have a constant rate of change, and that's going to be our velocity. So this is our original velocity, our initial, but that doesn't change. That's always going to stay the same. Okay, and because this is not changing, again, we have our acceleration at 0. So for our vertical motion, a little bit different. So for horizontal launch, we start at some height, our initial height, and then we're moving to the ground. It is projectile motion because we're starting high, and then we have the acceleration due to gravity working on it. So because of that, and take a look at this position time graph, it is a concave down curve, so that's your smiley face, right? Your sad face, really. And when it hits the ground, our y position equals 0. If we were to take this and find all the velocities, we know that our initial velocity is 0, and it turns out that the slope is going to have to be negative 9.8 here, because we know that the acceleration due to gravity is negative 9.8, and the slope of our velocity time graph is our acceleration time graph. Okay, so for the next part, notice this slope of our velocity time is always the same. The difference is our initial velocity has some value. So what's happening here is we are slowing down the whole time. All right, so even though the vertical position is increasing, we hit this max point and it comes right down. We're starting at a speed of, let's say this were 10 meters per second. We're starting there, and it's slowing down each second because the acceleration is negative 9.8. So we're slowing down. This should say Vy equals 0 here. So at max height, we know that the velocity there is 0. And then once we hit that 0, now my velocity is starting to speed up again. And again, when it hits the ground, my position is 0. Okay, so here you can see I have some positive speed here, and then I'm slowing down. I stop here, so this maximum point, this is where, when this graph equals 0 on my velocity time graph, I know that is the maximum position of my object that is being projected. And again, the acceleration due to gravity is negative 9.8. So then for the angle launch, the only difference is that we have a position that is starting. So this is my initial position, and then again I have this max velocity, which is 0 meters per second, or whatever units we're using. Here I know that y equals 0 at the ground. All right, so the difference is here my initial velocity and my final velocity are going to be, they will not be equal and opposite, right? So here, like wherever this was at, this distance right here, that's going to be over here. These are equal and opposite speeds right here. Okay, so this is where my maximum is at. That's when my velocity was 0. That's here. But there's more time after that max to try to get it to hit the ground than before that maximum point. So you'll notice the majority of my graph here for this given time is going to, this is going to be the longer piece of your velocity time graph. And again, the slope of this is just the acceleration due to gravity.